right, so what we have here is a graph of a function f of t. And I will tell you right now that it is 4 straight lines. I'll number them. One. Hopefully you can find the office without getting lost. 1. This one from here to here, this whole segment is 2. You notice the slope stays the same the whole way. It doesn't quite look straight. Then it goes from here to here. This is segment 3. Then it goes here to here, segment 4. So there are 4 line segments, okay? The slopes of each of those segments are the same throughout. And that is a piecewise function. And then I define g of x as the integral from 2 to x. And I ask you a couple of questions here. I ask you for 2 values, 4 and 5, and then I ask you for the derivative at 0. All right, so everybody, we have what we call a fundamental theorem of calculus problem, that we can define the area under the curve as a function g of x, all right? That's here in red, all right? And the first thing I ask for is g of 4 and g of 5. So if I move those out from the left side of my board to the right side, so it's in the dead spot, and I can write over here. First thing, does everybody understand? It's simply this, right? And this is defining what? The area under the curve from 2 to 4. Everybody, the area under the curve from 2 to 4 is simply a triangle, right? So I'll bring on the triangle, all right? That triangle is 2 tall, 2 wide. And I just took the dimensions from here and here, right? 2 by 2. No, 3 tall. 3 tall, 2 long. I'm sorry, I got to read the coordinates better. 3, does that look better? All right. So, everybody, we know the area of a triangle is 1/2 base times height. So I think the answer is simply 3. And it's under the axis, right? So it is -3. All right? My expectation here is I wouldn't care if you drew the shape. All right? All this crap I'll just erase. Now, to find g of 5, we're not going to reinvent the wheel. I'm going to do g of 4 plus the integral from 4 to 5 f of t dt. And we should recognize this as being the same, or modifying the red one with the appropriate thing here, right? And the 4's match. And anytime I want to do that, I can. All right, so here I go. And I get, we just found it's -3. This triangle is 1 by 2 up here. Okay, 1 by 2. I think the area is 1. So I think the answer to g of 5 is simply -2. All right. So those are the 2 values we found. I might make you find. My question to you at this point, if I had this as a final problem, would be: is the area ever positive? Okay. Why or why not justify? We'll talk about that in a second. If you want to start thinking about that instead of being bored. Oh, is it? Yeah. Next one is find g prime of 0. If you're going to find g prime of 0, you got to find g prime. Fundamental theorem of calculus. Again, this is like yesterday. This should take us all of 2 seconds. G prime is just a function. So if I want g prime of 0, I'm pretty sure when I look at f of 0, the answer is simply g prime of 0 equals f of 0 equals 3. All right. Everybody, there'd be 2 questions that I could do. All right. We'll do it 2 ways. We'll start with the hard question and work back. We're gonna do that second question we talked about in a second. Shoot. Where is all right? What regions? Where is g prime prime less than 0? All right. So I'll give you a second on that. The big step here, guys, is making the step of where is G prime where is G prime prime less than 0. You got to back up, and before you jump off the bridge, you have to understand that we defined right here that G prime of x was equal to f of x. So we got to know what G prime prime is. Derivative of G prime is G prime prime. Derivative of f of x is f prime of x. We want to know where this is negative, right? So we want to know where this is negative. If I have a graph of f of t and I'm looking for the derivative to be negative, a negative derivative simply means the function is decreasing. So we look at the board at the top, we're looking up here. When I look at the top, where is the function decreasing? 0, 2, 2. Right? Here is the only place that function decreases. Why? It's the only place where the slope is negative. So our answer to this question is simply, and I suppose it would be t, or it would be x, right? Because it's g. From what? Nah, wrong bracket. From 0 to 2 would be the interval. You guys agree? From 0 to 2. And that's where G prime prime is negative. All right? The other question I asked, and we're going to do this one next, all right? I'm going to gather all this up. And again, you got to kind of practice. So obviously, back up. Before I do the next question, the other question is, where would G prime prime be positive? Well, how about everywhere else? Except you would have to say 2 to 4 and 4 to 5, because that's a point that it's definitely got some problems there. Do you agree? The derivative, the slope coming in, the left hand and the right hand don't match, right? The slope here is not the same as the slope there. All right?
So it's still continuous, it's just not
Differentiable.
yeah.
It's continuous but not differentiable. Exactly. All right. So the next question, though, that I would ask, and this would be the one that separates A's and B's. All right. So if you're saying, Mr. Anderson, I'd be so happy with a B. But the question would be this. I probably would ask something like this: can G of x have a positive result? Why or why not? And then it would be the word probably justify. I like the word justify. Justify your existence in calculus. Now this is the hard problem. I'm not even going to give you guys a chance to work on it. I'm not going to pause. We're going to keep on running here. Do we agree we have discovered the value at G of 4, right? And we've discovered the value at G of 5, right? So everybody, I look at this, and I know that at G of 5, it is negative 2, and at G of 4, we discovered it is negative 3. What is G of 2? That should take us like 2 seconds. 0. Guys, if I put 2 in here, 2 to 2, is there any area under the curve? No. But you notice I didn't say non-negative. I said positive. So we knew there's always a 0. The question is, what if, is it ever going to be positive? Now we're going to have to work left of 2. All right. I think we can answer this question right now looking at the next region, because we're going this way, right? And this is under the curve. So that area is negative until you invert the integral. So the answer to this question is yes. And it's going to happen from 1 to 2. And I'm going to show you why. The answer is yes, and the justification would be what I'm going to write now. And it'll show you why. So we know it didn't happen going right, all right, from all our questions. But here's what I would do. I would see that triangle, and I would immediately, and again, how long have I been doing this calculus stuff? Well, for a long time, probably longer than you guys have been alive. All right, so I can make this look easy, but everybody, I would simply do G of 1. And we all agree that's from 2 to 1, f of t dt, right? And then I would simply write negative 1 to 2 f of t dt. negative, and I look up here, and I'm going to go a little bigger so we can see the whole thing. I can see this triangle under the curve, right? 1 by 3. Under the curve is negative, right? So negative 3 halves. And what's the result at G of 1? At G of 1, it's positive 3 halves. So I could explain it that way. What if I wanted you to justify if this was a max or a min at G of 1 then? You do that. Last thing we're going to do on this tape. Alright? We just proved that. What is happening at G of 1? Is G of 1 a max, a min, or just another point? Alright. When I look here, do you guys agree that G prime is f of x? And when G prime, when a derivative goes positive to negative, what do we get? Max. That's what it does here. F goes from this derivative. F goes from being positive. I'm looking at the value, not the slope. I should be looking at the value. I'm sorry, an arrow's probably back. It goes from positive to negative. You guys see? Moving right to left. So guess what? I know that G of 1 is a maximum. And I know that as I go further back, I can tell, thinking about it, that this is going to become negative again. The area under the curve. Okay? All right. Fundamental theorem of calculus. In our book, this is section 5.2 and 5.3. Don't surrender. Keep on practicing.